Hey there, STEM Spark enthusiasts. I'm so glad you're here. I'm Courtney, and welcome back to the STEM Spark, where we ignite curiosity, creativity, and confidence in every learner through science, technology, engineering, the arts, and math. Today, we are turning off the lights and turning up the glow. Have you ever wondered why some things glow in the dark or how glow sticks work? We are diving into glow science, the chemistry and physics behind light and color. And then we'll explore a bunch of glowing experiments you can try in your home or your classroom. All right, this is my favorite week of the whole year. I do glow science the week of Halloween. I transform my whole classroom. I do decorations. We have black lights all over the place. I use tape and things like this that glow to decorate. I have all kinds of things that I use. This is a whole kit, and so lots and lots of glow options out there. It's super fun for the kids to come in, and the room is completely dark minus the purple hue of the black light, and they are amazed. I am hoping that they will be just as enthusiastic as they were last year for this year's glow activities. Okay, so the science of glow. When something glows, it releases energy as visible light, and that light can come from different processes. Scientists call this luminescence, which means light without heat. Okay, so that's luminescence. Let's look at a few ways that this can happen. So first off, you've got fluorescence. We're most familiar with this with fluorescent lighting. Fluorescence happens when something absorbs ultraviolet or UV light, which we can't see, and gives off visible light, which we can see. Okay? Highlighters are a great example. They're so glowy. Tonic water, also a beautiful example. And some laundry detergents also contain fluorescent materials that glow instantly under black light. When the UV light turns off, the glow disappears. All right, let's talk about phosphorescence. Phosphorescence is what gives us the glow-in-the-dark toys. So these materials absorb energy from light and then slowly release that energy, glowing for minutes or even hours afterwards. Okay, so I'm thinking like the stars that you put on your ceiling in your bedroom kind of thing. Super fun, lots of different glow-in-the-dark kind of things. The one thing I do love about this is the glow-in-the-dark also fluoresces under the UV lights, and so super fun on that one. And then you have chemiluminescence. This occurs when a chemical reaction releases energy as light instead of heat. Okay, so now we're going into glow stick territory. When you bend a glow stick, you are breaking an inner tube inside of an outer tube, and the two chemicals mix together and it releases energy, and the other converts that energy into light. All right, so that chemical reaction is creating the light. All right, and then you have bioluminescence, and this is nature. Nature glows too. So we're thinking fireflies, jellyfish, and certain types of deep sea fish that make their own light. This is through a chemical reaction inside of their body. They use it for communication, attracting prey, or hiding from predators. So super fun science in action. So whether it's chemistry, biology, or physics, glowing always comes down to energy changing form from one type, like chemical or UV light energy, into visible light. So, light, energy, and color. Light is a form of energy that travels in waves. Each color of light has a different wavelength and energy level. So, ultraviolet light has a shorter wavelength and a higher energy than visible light. When fluorescent materials absorb UV energy, their electrons jump to higher energy levels. When those electrons fall back, they release that energy as visible light, and that is the glow that you see. Isn't that fun? Science in action. Temperature can also affect glowing reaction. So things that are warm, it's going to speed up those molecules and make chemical reactions go faster. So a glow stick in warm water is going to shine brighter than one in cold water, but the brighter glow stick is also going to fade faster because it uses up that energy really quickly, while the one in cold water is going to glow dimmer, but it will last longer. And so that is why we were always told to put your glow sticks in the freezer if you want them to last, because it slows down that energy and makes it last a little longer. All right, so now let's talk about the Glow Lab. So I have activities, experiments, and questions, along with just some fun things to do for your Glow Lab. Let's get glowing. So here is a collection of experiments, experiences, challenges, and games that will explore the science of luminescence. Each one includes a critical thinking question you can ask learners to deepen their understanding. All right, so one of the first games I ever played with my students on Glow Week was What Glows? So I would give them a list of items, and they had to write down a prediction of whether they thought it would glow or not. And then I would show them, and they would have to tell me. So I'm going to turn this over just a little bit so we can have a little bit more glow. So I've got a banana here, and believe it or not, bananas actually glow in the UV lighting. We also have some tonic water. Tonic water definitely glows. The quinine in that makes it glow. I've got clear tape, and clear tape glows. That's kind of fun. And then I've got a coaster, and there are like speckles that kind of glow if you're looking at it in the right way, but for the most part that does not glow. You can use just everyday objects like cups or different things around your room. Eggs glow. How fun is that? All right, so basically, again, I just give them the list and they predict whether they think it's gonna glow or not and write down their prediction, and then I show them with the black light what glows and what doesn't. Okay, so all kinds of different options on that. And then the science tie-in is observation, prediction, and testing. And then what patterns do you notice about the things that glowed versus ones that didn't? And what do they have in common? So that's super fun to think about and for them to experience. And then they could maybe make, once you do the pattern question, they could maybe make even more accurate predictions about some other things. So super fun. And they will also start to just naturally think of things, which is super great. I love seeing that happen. All right, the next activity is a game, Glow Bingo. Make bingo cards. You can use black or white paper and highlighters. You could do just a number bingo if you have younger students. You could do different words or different things that actually glow. So if you do the prediction game, maybe as they write down their predictions, they just fill in a bingo card and do something like that. You could do like UV light, glows under UV light, fluorescent, chemical reaction, and then show different pictures of different things. And then they could mark them off as you either discuss it or call out words. The science tie-in for this is vocabulary building and concept recognition. There's a math tie-in of just using numbers and highlighters. And then a critical thinking question would be, why do you think it's important for scientists to name and categorize different types of glow? All right, our next activity is glow slime. You know, I am not a fan of slime. I just don't like it. With this one, I mixed, I didn't actually use clear glue. The directions did say to use clear glue, but I just used regular glue and put some paint in it. And so it's got that wonderful little green color. And I will tell you, because some slimes are just too sticky and some are too gooey. So if it's too sticky, the thing that I have found was a little bit of extra baking soda makes it a little less sticky. And then if it's too gummy, a little bit more contact lens solution helps that. But this one turned out pretty good. It's got a good consistency and a really great glow. All right, so you can make glow slime. It's just glue, baking soda, contact lens solution with fluorescent paint. You could also mix in a little bit of tonic water. I probably wouldn't do a whole lot of water in this. The recipe I had was actually pretty spot on, and so it worked out really well. But you do what works for you on the slime. What kid doesn't like making slime, right? It's also a great way for students to see chemical reactions and how those chemicals are mixing together, as well as some measurement. Always love to throw in that math. A critical thinking question for the slime is, how does adding fluorescent paint change the slime's appearance? And what does that tell you about how light interacts with materials? So, very cool. All right, I do not have an example of this one, but I do intend on doing it this year, a glow rubber ball. So for this one, you're going to combine borax solution, which you find in the laundry aisle, and fluorescent glue to create a glowy, bouncy polymer ball. So the science tie-in for this one is cross-linking polymers and material properties. I am going to do this with my middle school students, and so it's got a little bit higher level thinking involved in that and higher level science. The question I have for this activity is, why do you think the glow is more visible in some parts of the ball than others? That could also be a good question as you are doing the slime to ask about with the slime, because you really have to mix it up to get that good glow all throughout. And so that could be a great question to ask for both of those. Okay, the next one is the science of glow sticks temperature test, which I did talk about this a little bit in the intro, but basically you need 3 glow sticks. I like to use all the same color so that they can really compare. And you're gonna crack all the glow sticks, talk about the 2 chemicals, mixing it up, all of that. And then you're gonna put 1 in hot water, 1 in room temperature water, and 1 in cold water or ice water. and then just have them observe the differences. The reaction rate and energy transfer are your science tie-ins on this, and kids seem to get it really easily, and they really enjoy this experiment. The question for this experiment is, how does temperature change the glow, and what does that tell you about how energy affects chemical reactions? So super fun, great learning experience, and the kids really love it. They really get into those kinds of questions and watching the differences. Okay, our next activity is glowing cloud dough. So I love cloud dough. It is one of my more favorite experiments to do. With this one, you're going to use cornstarch and white or really light colored hair conditioner. And then you just add in some fluorescent paint or some glow paint, and it makes a super fun, it smells really great, depending on your conditioner, cloud dough. So, super fun. You get to squish and squeeze and make all kinds of things under that UV light. The science tie-in for this is states of matter and mixing materials. And then the critical question would be, what do you notice about how the dough glows when you stretch it or compress it? So that's a very interesting question for them to think about. All right, I will say with this one, you do have to get your measurements pretty exact for it to work really well. So I am going to play around with my recipe because right now I don't love it. But in general, it's really great. All right. The next one is a glow egg. Again, I did not do this one as an example, but you just take a raw egg, you put it in vinegar, and vinegar dissolves the shell, and then you can soak it in either tonic water or regular water with the inside of a highlighter. So if you pull out the highlighter ink sleeve and put that in the water with the egg, then it will absorb that and it will glow. And so it's super fun. It's great to talk about acids, bases, calcium reactions. If you can do the entire experiment with your students, it does take several days, a couple of days to dissolve the shell, and then a day or two to absorb the water. So if you can do that with your students over the course of a few days, it's really great for them to see the whole thing. But if you can't, then I would go ahead and dissolve it, soak it in the solution, and have the glowy egg as your demonstration. It will also sort of kind of bounce as well. All right. The question for that is, what do you think happens at a molecular level when the vinegar dissolves the eggshell? And it's super fun for them to see that part of it because it is an immediate reaction. The bubbles are automatically forming as soon as you put that egg in the vinegar. And so it's super fun for them to watch that because it is so immediate. All right, the next activity is a glow building challenge. You can use glow sticks. You could use neon straws and build different types of things. All right, for this one, the science tie-in is engineering and design, geometry. I actually have the straw and connectors, so I will probably let them use the connectors from that to help them build with the neon straws instead of like the regular ones. So if you have those, that might be a good option. All right. The critical question for that is, what design changes could make your glowing structure stronger or more stable? Another way you could do that is using cups. You could get neon cups and the neon index cards, and they could build using cups and cards. You could even throw in some straws and connectors in that, but that could be another way to build, or for younger students to incorporate a building challenge. All right, the next one is for younger students. So you can do glow words with highlighters and paper, or you can do rice words. So what I did is I took a big bag of rice and I split it into different colors or different bags, and I put a little bit of the paint. I just bought this. It's not glow in the dark. It's just neon paint from the local craft store, and a few drops in there with some a little dash of water. Put some air in it and then shake it. Lay it out super flat to dry on some parchment paper, and you get this beautiful glowy rice. And students of all ages like to draw on it and play with it. Even my middle schoolers wanted to draw on it. They just loved it so much. I have the cookie sheets that I use in my classroom. You could also use just a paper plate and put it on there. I guess you could just spread it on the table. I think that would be harder because we just shake it to get the picture out and start over. So that might be a little easier to have something to do that with. The science tie-in is observation, and then the literacy integration with words. You could even do shape recognition, or you could even have them tie in some math with write 1 + 1 and tell me what it equals kind of thing. So lots of different options with that. The critical question is, how could you use glow writing to communicate or display information in a creative way? So that would be fun for kids to think about. All right, the next one is a glow lava lamp in a bag. I do not have an example of this one either, but basically you're just going to use some clear oil and then a little bit of water, tonic water, and then food coloring. I actually would suggest doing the watercolor neon paints, or I think they might even have glow-in-the-dark watercolor paints. If you use the oil and then the watercolor paints, it will do the same thing, and you don't have to have Alka-Seltzer or anything else. So if you do that, you just put it in the bag, take some tape and seal it up so it doesn't make a mess, and then you can just run your finger over it and it just does bubbles and it glows under the black light. Super fun. So the science tie-in for this would be density. If you do use the Alka-Seltzer, you could talk about gas production and reactions. And the critical question for this, why do glowing bubbles move the way they do? And what happens if you change the amount of oil or water in your lava lamp? Super fun for them to think about and maybe even go home and do. All right, the next activity is a noodle sort. So I have noodles of different shapes and colors and styles. Some of them glow more than others. But basically, I just put all of these out on a pan, the same pan, and then they use tweezers to sort them into the different things. And so you could give them their first sort. The next sort, you could ask them a critical question. How could you sort the noodles using a different rule besides color? And it was really fun because we did color and then we also did shape. And then I asked them, okay, what else could we sort by? And they said some of them are broken. And so they wanted to sort the broken ones out from the non-broken ones. And I thought that was really clever. So super smart. Lots of different ways you could sort those. So the science tie-in is sorting, classification, and visual perception. And then I already told you your critical question for that. The next one is a Q-tip painting. So I basically just put some of the neon paints at each table. Each color has a Q-tip, and then they get a black piece of construction paper, and they get to paint a picture using the Q-tips on their paper, and it glows really pretty. So the science tie-in is fluorescence, and then you have that art pull-in as well. The critical question for this is, what color combinations glow the brightest, and why might that be? Super fun for them to do that and to think about. Another simple one, and this is our last one that I have for you, is highlighter drawings. I just hand out white paper and highlighters, and they just go to town. They love it. Some just write their name, some draw a pretty picture, but they absolutely love drawing with the highlighters under the black light. Super simple activity, not a lot of prep. Another way you could do that is to do a darker color paper, construction paper, and have them write on it, can they see it in the regular light versus the UV light. The science tie-in for this is fluorescence and UV absorption. And then the critical question, why can't we see the writing in normal light, but we can see it under the UV light? All right, the big takeaway this week, when things glow, we're actually watching energy transformations in real time. Whether it's UV light exciting electrons or chemicals reacting to release energy, glowing teaches us about the deep connection between energy, matter, and light. Glow science blends chemistry, physics, and even art, showing that when learning lights up, understanding does too. All right, STEM Spark viewers, I'll leave you with this final question. What glow experiment or activities will you do? Pick one or two glow lab activities, grab a black light, and see what you discover. It encourages learners to ask, what's happening? Why is it happening? And how could I change the results? All right, take a picture of your glowing creations and share what you learned. And remember, always practice safe science when working with lights and chemicals. Thanks for tuning in. Don't forget to follow the show, like this video, subscribe to the channel, and share it with a fellow educator, parent, or STEM enthusiast. I'll be back next week with more ideas to keep your STEM glowing bright. This is Courtney with the STEM Spark, where curiosity sparks creativity. Bye.